Welcome to a little homework help, Unit 7, Lesson 8, combining bases. We talk about this first problem. It says select all the true statements. When we look at these, we need to consider the piece that we've talked about, the product of powers. And that's the first one right here, where we recognize that we're multiplying and we have two bases that are the same. So when the bases are equal to each other, we can simply take that statement, 2 to the 8th power times 2 to the 9th power, and extend that to become something that is just a much longer multiplication problem, where 2 times 2 times 2 times 2, you get the point, right? Over and over and over again until I have all 8 of them and then all 9 of them all listed out. And we see that I would eventually have just a simpler scenario. Product of powers is when the bases are the same and I'm multiplying, I can take the sum of the exponents. What we also learned in this lesson is that there's another way that we can look at this. When we look at the second example right here, is when we have something where we see 8 to the second power times 9 to the second power equals 72 to the second power. What we can think about with this is we think about how can I take this value over here and break it up into different factors. When we look at the factors of 8 and 9 and we multiply them together, we get a product that's actually equal to 72. When we put a squared value outside of that, we're still saying that this value right here inside the parentheses is 72 and it's raised to the second power. When we consider the piece about having a product of powers or a power of these other powers inside, we consider the fact that we would take, and by some accounts, distributive law, we would take the 8 raised to the second power, and we would take the 9 also raised to the second power. And we see that this expression right here ends up being the exact same as this expression, which is equal to 72 to the second power. So we should be selecting option B, option A. Now, the reason this does not work for option C is because these two bases cannot be combined together. And then because we can't combine them together, we cannot multiply the exponents together. So item C is out. Letter D, we have to look at the product of powers piece again. There's no way to get 4 as a base for this problem because we don't multiply the bases together. Otherwise, we end up with something totally different. We end up with something of 4 times 4 times 4, right? 17 times. And we don't want that to come out that way because the bottom line is this. 2 to the 17th power is not equal to 4 to the 17th power because the bases are completely different. So letter D is also out. All right, let's move on to the next one. This says find X, Y, and Z if we have this great expression here. So when we consider the expression, what we need to recognize is this. We have 3 being raised to the 4th power. We have 5 being raised to the 4th power. Then we have in the next group 2 to the 5th power and 3 to the 5th power. And then in the final group, we have 2 to the 7th power times 5 to the 7th power. What we can do with this is use a little commutative property and combine our like bases. So we have 2 to the 5th power times 2 to the 7th power times 3 to the 4th power times 3 to the 5th power times 5 to the 7th or 4th power times 5 to the 7th power. And then it's just a matter of using product of powers to combine the exponents of the bases that are alike. And so we have 2 to the 5th and the 7th, which makes that a total of 2 to the 12th. Then we have a total of 3 to the 9th, 4 plus 5. And then the final one is we have 5 to the 11th power. And then when you look at our values right up here, we can see that this is 2 times X times 3 times Y times 5 times Z. And then when we look at those pieces, we just recognize the correlation that X equals 12, Y equals 9, Z equals 11. There you go. Make sure you put this in here. Make sure that you answer it like this, the way that it says, with no spaces. The value of z or of x comes first. Don't put x, put whatever number it is, a comma, no space, then the value of y, think back over here, and then z for the final value. Final problem is we have Han. He found a way to take a complicated expression and make it a little easier. And here's what his big, like everything hinges on this. He said since 2 times 5 is equal to 10, he looks at pairing up 2s and 5s that he knows equal 10. So what he did is just kind of the same thing like we did in the previous problem. He broke down this expression, 3 times 2 to the 4th times 5 to the 5th, and he rearranged it a little bit so that he would get 2 to the 4th power and 5 to the 4th power. The goal that he's using here is that exponent product rule, where if the exponents are the same, then I can just multiply the bases together to get this value right here, 10 to the 4th power. So you see where he did his work right here, and he had 10 to the 4th power. What he had left over was a 3 and a 5, and they came into their own separate group. So now how could we use this with Han's technique to, or use Han's technique to compute the following? Well, I see 2's here, a 5 here, and then this is a little bit different at the very end. This is 2 to the 4th times 5 times 3 to the 3rd times 5 to the 3rd. And now by regrouping these together, we can actually find another way to work with this using Han's method. 2 times 5 is 10. So we see that this is 2 to the 4th power times 5 times 5 to the 3rd power times 3 to the 3rd power. Now that 3 is going to be kind of the wild card. That one's out right now. And you might be saying, well, the exponents are not the same for the 2 and the 5s. If we remember the invisible power for 5, then we understand that we have 2 to the 4th times 5 to the 4th, which means that we can group those two together to give us 10 to the 4th power. And then we would just simply multiply that by 3 to the 3rd power. I'm going to leave the rest of that to you to simplify to an actual number. Please don't leave it in this format, but simplify it out to a number that can be used for this situation. In part B, Han did it again. Again, what we're looking for is matching up, finding some 2 to the 5th, or 2 times 5, because 2's and 5's you know equal 10, and powers of 10 are a lot easier to work with. I would suggest the very first thing you do is take expressions like these and switch them to 2 to the 2nd power times 3 to the 2nd power, and then 3 to the 2nd power times 5 to the 2nd power. You might be saying, well, why did I use that little x? Because that's what they had there. There's your multiplication. Now, what we're left with is 2 to the 3rd times 5 to the 2nd times 2 to the 2nd times 3 to the 2nd times 3 to the 2nd times 5 to the 2nd. But we're going to divide by 3 to the 2nd power. So here's the cool thing is by this division rule that says anything divided by itself equals 1, we can get rid of one of those. And then we want to go ahead and rearrange so that we get all of our 2's, bases of 2's. Let's put all them together. Put our bases of 5 next, because we're seeking to go ahead and combine those together. And then we'll put our power of 3 out here. The last piece, we have all of our values there. And so now what we want to look at is this. We have our 5's that become a 5 to the 4th power. And then our 2's would become 5 to the 5th power. That's one too many 2's. So if we take out one of those 2's, make this 2 to the 4th power times 5 to the 4th power times 3 squared, what we end up with is an opportunity to make a new combination here. We can take the 2 and combine it with the 3 over here, which will make it just a little bit of a different situation. We have the 2 and the 5 are being raised to the 4th power as a group, making this 10 to the 4th power. Forgive me for writing over top of the next problem. You won't need this, but what we see is 2 times 3 squared, which actually means that we're multiplying this times 3 times 3. 3 squared is 9, times 2 is 18. And so when you figure out what that is equal to, 18 times 10 to the 4th, you can put that number right there. All right, that's it for the homework help. Reach out to me if you have more questions or if you need some more explanation. Have a great day.